Well, good morning, good afternoon, everyone, and welcome to another exciting Exploring by the Seat of Your Pants broadcast with us. I know quite a few of you are joining us for the first time this year, in which case, welcome to the show. We are all about bringing conservation, adventure, and science into classrooms around the world. Now, this is our 30th broadcast of the year already with some of the coolest scientists and explorers on planet Earth. Everything we do goes to our YouTube channel, so if you want to catch this one later, share it with family and friends, there's lots of opportunity to do just that. I do want to note today, before I introduce our epic speaker, that we have a Kahoot today as well. So between our talk and our Q&A, if you want to play along with a little 4-question quiz, you can pull up that game pin in a separate taskbar at the top, and we'll have a little bit of fun together before the question period. Now, that epic volcano intro is the first time we've had the chance to use that this year because we have our most epic speaker that ever comes on the show. In fact, he's come on more than anyone else in Exploring by the Seat of Your Pants history, and that is world-trotting adventurer and explorer George Kourounis. He is just coming back recently from a Northwest Passage expedition. He's been to Alaska, Greenland, New York, all over the world, both this year and every other year, because he is pretty awesome. So today he is going to join us and talk to us about really, really cool, weird and wacky weather, some of the most amazing phenomena on planet Earth. And so without further ado, I'm going to stop talking. George, welcome back to the program, man.
Thank you so much, my friend Jesse. It's good to see you, and it's really great to have everyone who's tuning in from all across North America and beyond. I'm not sure where you're all coming from. There could be who knows how many people tuning in on YouTube from the moon. Who knows? But anyway, my name is George Kourounis. I'm a professional explorer and storm chaser, and I spend my life traveling around the world documenting the most extreme forces of nature and natural disasters, and then I share what I've seen with as many people as possible, quite often through venues just like this one. And what we're going to talk about today is weird, wacky weather. And not just like rain or snow. We're going to get into some really weird stuff, some extreme weather, and then also a few different weather phenomena that are really unusual, really pretty, very strange. I'm going to explain the science behind them. And some of these are things that you can be looking out for today or tomorrow or the next day. These are things that you can see without having to travel around the world or put yourself in the path of a hurricane. So let's get started. There's going to be some really cool stuff here. Stand by.
Well, and as you're pulling this up, George, too, I'm going to let the classes know I will be sharing all of George's info. He's easy to find on social media, has an amazing website. Like if you want to keep the adventure going, plus like literally dozens of other programs with him. So lots of cool opportunity to learn even more when we are done today. Looks like you are good to go, man. This looks fantastic. Let's do this.
All right. World's weirdest weather. Let's begin. So, of course, all of our weather here on planet Earth exists on planet Earth. This is where we live, all 8 billion of us. And of course, the Earth is rotating. It's spinning, and it spins from west to east. So as you're looking at it here, imagine you're in space looking back at Earth. It's rotating from left to right. But notice it's not just the Earth that's spinning. All of the weather that's on planet Earth is also rotating along with it. So as the Earth rotates, it brings all of the air, all of the atmosphere, all of the clouds with it. And I can't imagine what it would be like here on Earth if that didn't happen. If you're in a helicopter and you tried to take off, suddenly you'd be blasting off in 1,000-kilometer-per-hour winds. So luckily for us, our atmosphere travels with us, but that rotation of the Earth does have a really big effect on our weather. Mainly through something called the Coriolis effect or the Coriolis force. And so the rotation of the Earth affects the weather, and it makes weather spin in a lot of ways. So that's one thing that's really important about what I want to talk about today. So the way that this works is this Coriolis effect, this rotation of the Earth, causes big things like hurricanes to spin. That's why there are these gigantic rotating storms. And in the northern hemisphere, where I am, I live in Canada, hurricanes will rotate counterclockwise. In the southern hemisphere, they rotate clockwise. So sort of left to right in the northern hemisphere and right to left in the southern hemisphere. And so from this diagram, if you see you got that red arrow that's on the equator just off the coast of Brazil there, that represents air that wants to travel north. But because the Earth is spinning, it gets pushed to the right where that yellow arrow is. And air coming from the north gets pushed to the right, sort of towards the west. From our perspective, it looks like it's going to the left. And that's what gives this appearance, not appearance of rotation, that's what causes this rotation. And again, counterclockwise in the northern hemisphere, clockwise in the southern hemisphere, and that's why you will never have a hurricane cross the equator, because it would have to spin in one direction, stop, and then start spinning in the other direction, which they just can't do. It just does not happen. So keep that in mind. And here we've got like a satellite view of two different hurricanes, one in the northern hemisphere, one in the southern hemisphere, and you can see the different directions that they spin. So again, northern hemisphere, counterclockwise, southern hemisphere, clockwise. This also affects other types of weather systems. So, but does it affect smaller things? Like when you flush your toilet, right? Does the water spin one direction in the northern hemisphere? And if you lived in Australia, would it spin the other direction? Well, my friend Mr. Whiskers here is investigating that phenomenon right now. He's trying to figure out whether the Coriolis force will affect how your toilet flushes. Sorry, Mr. Whiskers, it does not. Your toilet is very small compared to the size of the Earth, and it's too small to be affected by that Coriolis force. It only works on big things like hurricanes, big storms, and tornadoes. And that's what I really want to talk about first, is tornadoes. And specifically tornadoes that spin the wrong direction. So I'm going to play a video here. And this is of a tornado that I was chasing a few years ago in Kansas. And there you can see the white funnel touching down. It's crossing the road right ahead of me. I'm driving the vehicle here. And you can see the debris passing in front of the tornado from left to right. So we know that this tornado is spinning what we call cyclonically. It's spinning counterclockwise. It's spinning the proper direction. You can really see that dirt getting lifted up by this tornado. Luckily, it's not hitting any houses or farms or anything. It's just grinding up the field. So that's good. It's not harming anybody. But here you can really see it's spinning left to right. So that is a normal tornado for North America. But not every tornado spins that way. There are some very rare tornadoes. Less than 1% of tornadoes spin the wrong way here in the Northern Hemisphere. They spin clockwise. And it's such a bizarre phenomenon. Tornadoes are rare to begin with, but these tornadoes that are spinning the wrong direction are even more rare and super weird. So I'm going to play a little video here of a tornado that I filmed in Nebraska. And it's going to be a little bit harder to see, but you'll see the funnel coming down. There's the funnel, and you see there's a bit of debris at the ground. But notice the clouds around that funnel. They're going from right to left in front of the funnel. So this tornado is actually rotating clockwise. It's spinning the wrong direction from Nebraska. It doesn't make sense. It shouldn't do that. The Earth is rotating, and that force tells us how the tornado should be spinning, but here it's going the wrong way. So one of the main ways that this happens is if you have a main tornado, like this one here. This is from Kansas in 2016. There's a large tornado here on the left, and it's spinning normally, counterclockwise, cyclonic tornado. And then on the right, if you look closely, there's a smaller tornado, and it's spinning the wrong way, the anticyclonic, clockwise route. And we sometimes call that a satellite tornado. Think of how the moon is orbiting the Earth. It's like a satellite, right? Or like a Starlink satellite. They're orbiting around the Earth. Well, this small satellite tornado is orbiting around the other tornado, and in the process, it's spinning the wrong direction. So the main tornado is spinning one way, the satellite tornado is spinning the opposite direction, and it's going around the tornado. And when I took this photo, the wind at my back was tremendous. So what's happening is you have all this wind pushing into the storm, and on the left side of that wind the tornado is spinning one way, and on the right side of the wind, the tornado is spinning the other way. Imagine dipping your spoon into a body of water like a sink. Let me show this video here, and you get an idea of what's happening here. So as this person is pushing the water with the spoon, that's kind of like what the air is doing to the storm. And now you've got two little whirlpools that are formed. One is spinning one direction and one is spinning the other direction. So this can happen if you've ever paddled a canoe. You'll see this happen all the time. Sometimes if you stir your drink, you'll see this happen, where you get these two different vortices, these different funnels spinning in opposite directions. But in terms of a storm, it's super rare. We don't see it very often, and every time I do, it blows my mind. And we can detect these types of rotation in these storms by using weather radar. So if you've got an app on your phone for looking at the weather, you can see when the rain is coming. But there are some radars that are portable on the back of a truck, and these are storm chasers. I see these guys out in the field all the time, and they can bring their very high resolution, very high quality radar strapped to the back of this truck. And it shows us some really interesting things. Now, the image I'm going to show here, it's a little complicated, but I'll try to explain it. On the left side, we're seeing a radar picture of how strong the storm is. And on the right side, we're seeing a radar picture of what direction the raindrops in the storm are traveling, either towards the radar or away. So on the left side, we can see that circular spin here. It's obviously, there's where the main tornado is. On the right side, you've got the purple next to the red. That tells me that that's where there's a lot of strong rotation. If I see that on a radar image, I know that there's likely a tornado there. But there's some other cool stuff happening here. On the left side, we've got rotation going the opposite direction. That's the anticyclonic tornado. That's the one that's spinning the wrong direction. So here we can see there's actually two tornadoes happening at the same time. And this radar image is from the same storm that I showed you a moment ago with the two tornadoes. This was taken at almost exactly the same time. And it just so happens there was actually a third tornado at the same time on that storm, and it was spinning the proper direction. So we had two spinning right and one spinning, two spinning the correct direction and one spinning the opposite direction. And that is super weird, super rare, really unusual to have two tornadoes on the ground, let alone three at the same time. So that was just a bizarre day. All the conditions were perfect for creating these tornadoes. But tornadoes are very hard to find. They're very dangerous. What I want to go to next is some weird, wacky weather that you can see yourself. So there's this really cool phenomenon called sundogs. And they appear in the atmosphere on either side of the sun. And they look like these bright lights in the sky. Sometimes they're white, sometimes they've got a little bit of color in them, almost like a little mini rainbow almost. And they're always on the left and right side of the sun. And the only time you'll see this is when the clouds are just right. So we're looking for really high altitude clouds that are kind of uniform in consistency. We call these cirrostratus clouds. So if you're outside on a sunny day that has these wispy blanket of wispy clouds that seem to be very, very high in the sky, take a look just to the left or to the right of the sun, and you might spot one of these sundogs. This is a photograph I took just recently when I was up in Greenland. And we had the perfect conditions. You can see the sun is off on the left side of the screen. It's out of frame. But there you've got that sort of orange, reddish, golden sundog that has appeared. Now there may have been another one on the other side of the sun, but it was blocked by a mountain, so I couldn't tell if there was a second one. Sometimes there's one, usually there's two, and the way that these things form, you need to have just the right conditions in the atmosphere. So you need that cirrostratus cloud, that high blanket of wispy clouds, and then the ice crystals that make up those clouds. It's so cold up there that it's not raindrops, it's actually ice crystals, and they have to be flat with 6 sides. And because it has those 6 sides, sunlight is able to go inside these ice crystals, bounce around a little bit through a process that we call refraction, and then that light will then exit, come out of these ice crystals, and you'll see these sundogs. So that's a phenomenon that you could spot. Maybe if the conditions are right, maybe you'll see them today, this afternoon, when you go outside. If you're really lucky, the ice crystals will be in perfect alignment, and you'll get something called a 22-degree solar halo. And instead of having these little bright lights on the either side of the sun, you'll have an entire circle all the way around the sun. And so this is a phenomenon. It's not super, super rare, but if you don't know to look for it, you don't see it that often. So on a sunny day, if there's a little bit of high cloud, take a look and see. Don't stare at the sun, please. You'll hurt your eyes. Put your hand in front of the sun to block it, and or stand behind a stop sign or something, and you'll see this ring around the sun. But never look directly at the sun. And to give you an idea of how big it is, if you cover the sun with your thumb and hold out your pinky finger, that circle around the sun will be about where your pinky finger is. If you hold your arm all the way out, block the sun with your thumb, the pinky finger will show you about where that ring will be. And they can be quite beautiful. When I'm trying to photograph them, sometimes I'll put something in front of the sun. There's my friend Mark. He's also he's a meteorologist with the Weather Network. I was on a ship with him a few years ago and saw this beautiful halo in the sky. And I got him to stand in front of the sun so it's not so bright when I'm aiming my camera at it. Sometimes I'll put a tree branch or something in front of the sun to help block some of that bright, bright light. But yeah, they can be really, really beautiful. And they've got a little bit of that color in there too. Now, sometimes you'll see the full halo. Sometimes the clouds are not quite right, and you'll see just a partial halo. These are more common. So keep an eye out for that as well. And if you see this partial halo around the sun, keep looking, because maybe in half an hour, it'll be all the way around. You never know. Now, sometimes you can see these at night as well, which is really weird and really rare, but you can get lunar halos. These will only happen during like a full moon, either the day of a full moon or maybe a day ahead of or a day behind, because it needs to be really bright. So on those nights when you got a really, really bright moon, and again, you've got those high altitude cirrostratus clouds forming a thin veil of cloud high up in the atmosphere, you can sometimes see these halos at night. I've only seen it maybe a couple of times in my lifetime, and I look for it frequently. So these are super weird and super rare, but they do exist. And that's a photo I took from my backyard. Now, sometimes if the ice crystals in the sky are just right, you can get some absolutely bonkers, crazy displays of these halos, these really complicated solar halos. Now, typically you'll see these on really cold winter days when there's lots of ice crystals. And each one of these different phenomena, they all have a different name. I'm not going to go through all of these names, but some of them are really, really exotic. You can see that regular 22-degree halo, that circle around the sun. I'll just bounce back and forth here. And then up top, you see what looks like an upside down rainbow, kind of like the sun is smiling, or like the sky is smiling above the sun. That's something that we call a circumzenithal arc. I do not expect you to remember that name, but if you ever see a halo around the sun, look up even higher, way, way, way up in the sky. Crane your neck all the way up, and you might see that upside down rainbow. They're super rare. I've seen maybe 10 of them in my lifetime. So keep an eye out for those. If you ever happen to find yourself in a place like the South Pole where it's really, really cold, there'll be lots of ice crystals in the atmosphere. You may be lucky to see one of these really complicated halo displays in the sky. And it kind of looks like the sun would look like on another planet. Super, super cool. All right, there's two more phenomena I want to talk about, and then we'll get to the Kahoot. These are probably the rarest, coolest clouds that I can think of. They're called noctilucent clouds. And these are clouds that glow at night. And they're not the northern lights. It's not the aurora borealis. These are actual clouds. And you'll typically see them at really, really high altitudes. They look blue or silver, and you'll see them either right after sunset or you'll see them before sunrise. And these clouds are really, really high up there. If you look at the bottom left, you can see Mount Everest. Well, those clouds are way up, 80 kilometers up in the sky. Mount Everest is only about 10 kilometers. So this is 8 times higher than the highest mountain on Earth. We're talking about the edge of space. So, yeah, really, really high altitude. And you typically only see them in the summer for whatever reason. We don't know exactly why. And they're caused by small bits of dust really, really high up in the sky, up at the edge of space. And that dust attracts little bits of ice particles, these ice crystals that form on the pieces of dust. And it's got to be super, super, super cold. And what happens is when the sun sets, even though it's below the horizon and it's nighttime now, because these clouds are so high, the sun can still shine up onto them, which is really cool. But how do we get some of those little dust particles so high up at the edge of space? Well, there's a few really weird ways that this can happen. There's 3 that I'm going to talk about. Number 1, volcanic eruptions. Some volcanoes explode with such force that volcanic ash that comes out of the explosion can be shot way up to the edge of space. And that can help produce some of these noctilucent clouds. Sometimes meteors that come into Earth's atmosphere, as they break up and burn up as they're about to hit Earth, they leave a trail of dust behind them. You can actually see it in that little clip. And those can help contribute to creating noctilucent clouds. But also, we can help make them ourselves through rocket launches. When a rocket goes up into space, it leaves a trail of exhaust behind it. And as it goes up into space, the little particles in that exhaust can be left to orbit the Earth, and those can help contribute to noctilucent clouds as well. So in the summertime, after it gets dark, look up in the sky, and if you see these silvery bluish clouds that kind of look like northern lights, but they're not green or red, they're sort of bluish white. Those are clouds that could be formed by meteors and rocket launches and volcanic eruptions. I think that's super cool. One more thing I want to talk about, and this is really common. I think it's weird, but you can see this almost every day if you have a clear view of the horizon. And it's a phenomenon called the belt of Venus, and it's actually the Earth's shadow. So if you're watching a sunset, the sun sets, of course, in the west. And after the sun sets, if you turn around and look behind you and look to the east, sometimes you'll see a band of color along the horizon. It's usually like a bluish gray and then a bit of pink right along the horizon. And what you're seeing is the Earth's own shadow. So as the sun sets behind you, it drops below the horizon. I can actually demonstrate this with a flashlight. Imagine my hand is the Earth. And as the sun goes below the horizon at sunset, it's casting a shadow up into the Earth's own atmosphere. And it ends up looking like this dark band of color along the horizon. So the next time you're watching a sunset, after the sun sets, turn around and look behind you, and you might see this beautiful band of color, and that's the Earth's own shadow being projected up into our own atmosphere. And that's proof that the Earth is not flat. This wouldn't happen if the Earth was flat. Of course, the Earth is a sphere, and this phenomenon, all of these phenomenon actually, would not be possible if the Earth was not a sphere because of this, the directions of light with the sunsets and sunrises and such. And of course, the rotation of the Earth for these anticyclonic tornadoes. So anyway, there's a few examples of some weird and wild weather that you can actually see.
Oh, George froze for a second as we're coming out of his presentation. This is too exciting for everybody. Well, As George mentioned near the end of that presentation, while we wait to get him back, I think he's good and back now. We are going to go in with our Kahoot. So for those new to Kahoot, the faster you answer, the more points you get. And what you win is George and I's everlasting respect. So feel free to open up this game pin on the side of your screen. We're going to play along with this. We covered some elements of these, and then some of them I drew from other presentations of George. This is inspiration for all of you to go check out all of George's talks on our YouTube channel as well for some wild and wacky weather of a variety of varieties. So many of you coming in the Kahoot. This is amazing. Cool. Okay. By the way, too, I'll note for any students or teachers that are keen, we've got George's colleague Jacqueline joining us in like an hour and a bit too on Twister. So if you're really keen on some cool weather, lots to explore and discover there. But let's dive in. George, if you want to give us hints for any of these when there's like 5 seconds to spare, please feel free to do that.
All right, let's take a look.
All right. I'm so excited for one of these in particular, but it's something that I've seen that I want to see if you've seen, because they're pretty rare as well. All right, fire tornadoes are a thing now. Yes or no? George, have you ever been somewhere where maybe this could have happened, or maybe not, because it doesn't exist?
Maybe, perhaps. Maybe. Although one thing I can tell you, is that photograph is from Campo, Colorado. I witnessed that tornado. I can tell from the photograph.
That's so funny. The answer is true. We're actually starting to see these more with really intense fires. Alberta, the Fort McMurray fire famously is an example where we saw fire tornadoes and have confirmed this with science. So it's quite the sort of fascinating thing to think about. Our leaderboard has Rocky Dolphin in first. George, sorry, if you wanted to talk about that, go for it.
Oh, I was just going to say that sometimes wildfires are so intense that they can create their own weather. Yeah. And the heat rises very similar to the heat that's rising in a thunderstorm. And the fire can create its own thunderstorm. We call that a pyrocumulonimbus cloud. And sometimes if the weather conditions are just right, that can rotate, again, the Coriolis effect. And sometimes they can produce tornadoes in the wildfire that are, it's just amazing, combining wildfires and tornadoes. Like, let's take two of the worst natural disasters and smush them together. Scary.
By the way, pyrocumulonimbus is like the greatest name for a cloud. It makes it sound so metal. It's awesome. Let's
make a good band name too.
I hope you've seen all these pictures. Maybe they were all from you. I found them online. All right. What on earth is this? Is this a scene from a sci-fi movie? Is this actual aliens? Is it really strange lightning? Or is it a deep sea creature? We completely messed them up in the first one. I've almost never seen a 50-50 Kahoot before, so this is very fun.
It kind of looks like a jellyfish, but
it is really strange lightning. You talked about this in one of your last talks with us. What are those called?
I did, yeah. That's a red sprite. It's a type of really exotic, bizarre lightning that happens at extremely high altitudes above the top of thunderstorms. And we're only just learning about this type of lightning recently.
You've seen one of these before? Yes or no?
No, I haven't actually, but it's high on my bucket list.
I imagine it would be. I would love to see that. Honestly, so George did a talk with us. I think it's literally called Thunderbolts and Lightning. It's one of my favorite talks we've ever done. I've hosted 1,500 talks, and that is up there all time. So most of you got this right. Way to go. You didn't fall for my tricks. Rocky Dolphin keeps our lead. Question 3. Let's see. True or false again? An easier one. Volcanoes can produce epic thunderstorms. Okay. We were sort of talking about this with wildfire earlier. A lot of heat can produce their own clouds. We can create our own storms. Now, this, with most of our answers in, you've seen, have you seen this? You've been around so many volcanoes.
I have, and I can tell you right now, that volcano in that photo is Mount St. Helens from 1980, May 31st, 1980.
I got to stress for our kids who have never done a Kahoot. I've literally never had it. I've done like 300 Kahoots, okay, where someone's like, oh yeah, I know that. I've been there.
So yes, volcanic eruptions can produce thunder and lightning. What happens is, as the ash explodes up, the ash particles rub together the same way, you know, if you rub a balloon against your hair, it'll stick to the wall. That's static electricity. And if that static electricity develops enough, and there's enough of it, then you can get lightning bolts and sparks that happen. Same thing like touching a doorknob after you rub your feet across the carpet, but on a much, much more epic scale.
We got it really tight. It's a lead by 7 points, which is almost nothing. As we go to question 4. What are these? Contrails from planes, really cool natural clouds. It's an AI picture. or it's a Mario racetrack course? You sort of got this earlier with my other question about what it might be, so I'm hoping you're on the truth scale. George, have you seen these? This is a morning glory cloud.
This is, yeah, I can tell you right now, this photo was taken in Australia.
Yes. where they surf them, which is amazing. People go and they like have gliders to like ride these like a wave, which is insane.
Yeah, these are morning glory cloud. They are a type of roll cloud where there's a phenomenon called vorticity. Imagine a tornado rotates like this. Yep. Imagine the atmosphere rotating like this, and you can get these rolls of cloud. Imagine like rolling a tube from a paper towels across the top of your desk. You'll get the air sometimes does that. It can form these long streaks of clouds.
It's so freaky. So in Australia, there's a place where people consistently gather to go be involved with these and see them. I've seen it twice in Scotland, both times, which is really weird, and about the same coast. So I'm thinking that might be an area where they regularly form. But they are one of the most amazing things I've ever seen in my entire life. Morning glory clouds. All right, let's see what our winners are. And then Miss Coburn, we're coming to you first for a question. Everyone's going to get a turn, so stick around for a long Q&A period. Our winner, was it wire to wire? Rocky Dolphin came in second. Rockstar Bobcat takes the lead at the very end. If you are any of these folks, it's amazing, guys. If you are any of those folks, let us know who you are in the chat. We'd love to hear from you. But we're going to head to our Dalewood School first. Miss Coburn, if you have a question about your class, come on in and take us away.
First of all, George, thank you very much. We have some students joining us for the first time, and it's been amazing. So we have remote students, grades 7 and 8, and they're at home watching. So we've been working on narratives. So our question for you is, if you were going to write a story or a narrative, what would be your favorite character? Would it be the wind? Would it be the sky? Would it be a flying car? What would it be?
Oh, you know what? I kind of like your idea of the wind. Because to me, as a storm chaser, the wind takes on very different personalities in different situations. If I'm in a hurricane, the wind is very much a character in the story of me documenting that storm. And so to me, I think that makes a really good narrative character, at least in my world, it does.
I love that question. We've never had anything quite like that. So thank you, Miss Coburn. Miss Groot, I think that your mic is going to stay off because I think you've got some tech things. So please do share in the chat. We've got a few teachers that had a little bit of iffiness with the audio. So feel free to put any questions there and I'll pass them along to George. In the meantime, we're going to go to another virtual school, Mr. Bedard's class. Come on in, unmute your mic, and take us away with a question on behalf of your kids. Hey.
Hey, hello. You had answered your bucket list question, but I want to know, what is the most dangerous situation you've been in? How do you deal with it psychologically, physically? How do you deal with these situations? We want to encourage our students to become storm chasers and explorers. How do you do this safely?
Great question. I mean, I could talk for an hour just on that topic alone, but the more you know and the better educated you are, the safer you can be because you can understand what's happening around you. So in my opinion, and in my experience, education and understanding and experience are the most important things. And that allow me to get into these situations and understand how dangerous it can be. I was in the middle of Hurricane I blacked out there for a second there. I've descended down inside active volcanoes, and the way I do it safely is by understanding what's happening around me. And I do that by reading a lot of books and watching a lot of educational programs and spending a lot of time out in the field, working my way up to these different situations. I didn't start by doing this. I started off small by photographing storms in my backyard, and then eventually did more and more and more. So the more you know, the safer you can be.
I'm so glad that we got this question. We get this in almost every broadcast with you and some other high-level explorers, Jill Heinert, Jacqueline Whittle. I'm sure we're going to get it later. And universally, everyone has the same answer. Recognize the risk, prepare to avoid it as much as possible, don't take unnecessary risks, and you get to experience some of the coolest things that life has to offer while not putting yourself in sort of mortal danger. So thank you for that, Mr. Bedard. Great question. And Mr. Bedard was also our winner of our Kahoot. So way to go, guys. That was awesome. Janet Metcalf, Public School. Come on in, guys, and unmute your mic. You are good to go. Hey, welcome in.
Hello, how are you?
Hey,
good. Hey.
We do have a question. We have a couple, but we'll be mindful of that. How close, George, have you gotten to the tornadoes?
Oh, great question. How close have I gotten? Really, really close. There was one instance in Oklahoma one time at night while I basically drove into the side of a tornado, and there were pieces of debris flying everywhere, like driving through a swarm of bees. Transformers, the electrical lines beside me were exploding in these blue power flashes as they lit up the side of the tornado at night with the big blue explosions. So that was really scary. And what I did is I went and hid behind a shopping mall until the tornado had passed. And then I was able to get out and continue chasing it. So yeah, I never want to do that again. Thank you. But I have gotten really close, usually because I've made some mistake.
That's wow. I don't know if I've ever even heard that story from you, but that's a little too close. That's wow. Thanks for the question, guys. And we should be able to get back to you for a second one. So please do stick around for that. Mr. John's class, again, if you want to share in the chat, please do. We'd love to hear from you. But we've got a great follow-up question to the scary Twister experience, George, from YouTube. So Serena wants to know, what's the most Indiana Jones-ish adventure you've ever been on? And did it remind you of the Temple of Doom?
Wow. Well, okay. Wow. Indiana Jones-ish adventure. Well, I mean, I have been crawling around inside the pyramids of Egypt. So that's kind of very much a Indiana Jones experience for sure.
Oh, disappeared again for a sec. We'll get George back. It's exciting with the internet. I will note while we're... Oh, there he is. He's back.
I'm back.
You're back. You were in the pyramids, you were saying?
Yeah, I mean, I literally have crawled around inside the pyramids in Egypt. So I think, as an archaeologist, of course, Indiana Jones would do that kind of thing. So I felt very much like Indiana Jones when I was doing that.
Love that question. We've never had one quite like that, Serena. So thank you very much. Mr. Stelman's class, we're going to head to you. Our Dowling crew, we're coming to you next. We got some great ones from YouTube, and we'll try and do a second round together. Hey, Mr. Stelman.
Okay.
Welcome in.
Here, go for it, Dexita.
Yep.
Why and how did you become a storm chaser?
Nice.
Sorry, what was that? How did I become?
Yeah.
Why and how?
Why and how? Well, I've always had a love for science and nature ever since I was a little kid. And at first I wanted to be a marine biologist like Jacques Cousteau. And then as I got older, I got more interested in the weather and natural phenomena and the natural world. And I was working a full-time job as an engineer working in recording studios. I had a really great job doing that, but I would take my vacation time and I would study and study and study about all these different natural phenomena. And I would take my vacation time and I would go and I would learn from experts, team up with experts and learn how to chase these tornadoes. And then I would expand even more. Then I went from tornadoes to wildfires, to volcanoes, to hurricanes, to avalanches. And so it was a slow process, but all because of my love of science and nature. And I want to show people how amazing our planet is. We spend a lot of time indoors, and I want to show people how cool nature can be. And scary sometimes, of course.
You certainly do that in spades. Again, I'm going to pass along all sorts of stuff. You can check out George's other adventures when we're done to follow along with his amazing expeditions because, honestly, we don't bring on anyone who's done more to educate people on the wonder of the world than George. So great question, guys. And Miss Martin and Miss Steinhoff on YouTube, your class has asked the exact same thing. So that's fantastic. Keep those questions coming. We're going to head to our 4-5 Dowling crew. Hi, guys.
Rachel. Hey, Rachel. Go ahead, Rachel. What was your favorite adventure, wackiest weather?
Oh yeah, so your favorite adventure, the wackiest weather, George.
Oh, geez, the favorite adventure, wackiest weather. That's a really tough. I'm looking at my map right now above my desk. I've got this giant map of the world with all these pins stuck in it, and I'm trying to think what was the wackiest weather. Oh, geez. Hard to say, but one of the strangest things was weather underground. You can get weather underground, which was really cool. I was in a cave in Mexico that has the largest crystals in the world. These things are 55 tons and 10 meters long, 30 feet long. And the weather inside the cave was over 50 Celsius with 100% humidity. So we're talking so hot and humid that I had to wear a suit filled with ice, and I had to wear a respirator that allowed me to breathe refrigerated air. So it's really wacky and weird that you can have such extreme weather underground. So I thought that was pretty wild.
And you won't be surprised to hear, audience, that we have a talk with George doing that on our YouTube channel. So you want to see that cave and see him in his crazy suit. It's a lot of fun, and you can catch that later. YouTube, we're going to take a question from you. We're going to try and do a second round. We're going to be rebels together and go a little long today because George has so many great questions. Easy one, Miss Steinhaus class. Where are you traveling to next?
Where am I traveling to next? I don't know. Because it's hurricane season right now.
Yeah.
And I was up in the Arctic and I missed the last hurricane, Hurricane Helene. I would normally have been there for it, but I couldn't be there. But there's still quite a bit of hurricane season left. It goes until end of November. And so I'm sort of at home right now, waiting, watching the weather forecast and seeing what happens. And if there's another big hurricane, there's a pretty good chance that I'm going to be there for it. But I do have plans to go back to Greenland in March on a big ice skate. It's going to be amazing.
We're going to have circumnavigated that whole thing soon enough. It's a very,
Yeah.
It always sounds cool, literally and figuratively, to go to Greenland. Like that's a place that is always romantic and exciting.
I love it there. I've been there 4 times now. It's amazing.
Wow. Miss Groot's class has a couple questions on our StreamYard chat, so thank you for sharing there. There's some reports saying that we might be seeing the northern lights further south. Can you speak to northern lights in the south?
Absolutely, I can. Absolutely, I can. So there's a great big sunspot. It's an area on the sun where you've got these turbulent storms that are happening. And just yesterday, there was a coronal mass ejection, a CME, and it's blasted towards Earth. And so we're watching right now. We're expecting a potential solar storm tonight, tomorrow. We'll see what happens. I've literally just been watching it very, very closely on my phone. I'm excited about this. So I'm going to be possibly trying to find some dark skies tonight, maybe tomorrow night. So if you're in a place where you can see the night sky, if there's no clouds, watch for northern lights tonight, tomorrow night, maybe Saturday. We'll see. But certainly we've got an elevated chance over the next couple of days. It was a very, very big eruption from the sun.
When
9, I believe.
So
that's really, really high up their scale. Yeah.
We had this amazing aurora. I saw it in Newfoundland. People saw it all over Canada, certainly the northern United States, not too many months ago. And so after that, the next day, I took my solar eclipse glasses that I had from the big solar eclipse we had, and I looked at the sun, and you could see the spot on it. Like you could see this dark spot on the sun using those special glasses, and that's the only way you should ever look at the sun. But it's amazing.
That's a really great point. If you still have your solar glasses left over, if you happen to watch the solar eclipse back in April or May, whenever it was, put them on and look at the sun today. And you might be able to see, as Jesse was mentioning, these little spots. And that's where these solar storms are coming from.
Very, very cool. Guys, I know we're nearing the end of the day, or certainly lunch hour for a few classes. So we're going to take 2 more questions and then we'll wrap up. If you have any more, please email them to us at exploringbytheseatofyourpants, and we'll get as many to George as we can. But Janet Metcalf, we're going to come to you first, and Dowling will wrap up with you in a minute. Come on in, guys. Hey.
Hey, can tornadoes can they collide, and then can they be upside down?
Ooh. Well, I've never seen tornadoes collide. Many times I've seen where there's been 2 tornadoes, but I've never seen them like combine or anything like that. They do that in the movies, which is totally fake. That does not happen in real life. And in terms of upside down, kind of yes. Normally, when you think of a tornado, you think of a cone that's wider at the top than it is at the bottom. Sometimes they're slender, sometimes they're really wide. But sometimes you can get a tornado that looks like this, where it's a little more narrow at the top and actually gets wider towards the ground. And that's just because just the fact that you've got a bunch of rotating wind that is kicking up a lot of dust at the ground, and it makes it look like it's upside down.
Very neat. We've never covered that before, so thanks, guys. I've got a really, really quick one before we go to Dowling, but it's from YouTube, from your super Indiana Jones fan, and she wants to know if you've been to the Cave of the Crystal Sepulchre in Belize, which might be true.
I have not.
You've not? Okay, good to know. I just wanted to check. Dowling crew, come on in. Take us away. Hey, guys.
Have you ever seen a volcano erupt?
Oh, great question for George. Have you ever seen
seen
a volcano erupt? Tell him. Oh, we froze. Wait till he's back. You're going to get the best answer for this question ever. George.
Okay, I'm back.
The question was, have you ever seen a volcano erupt?
I have seen so many volcanoes erupt. Yes, one of the things that I do is travel around the world and document volcanoes as well. Sometimes working with teams of scientists, sometimes with television crews. And yes, I've seen volcanoes all over the world erupting. I've seen lava flows. I've lit my boots on fire, stepping on lava flows. I've had pieces of lava flying through the air and landing behind me. I actually even had my wedding. My wife and I got married on the crater's edge of an exploding volcano 18 years ago.
I'm so glad that's our final question. That's like the most perfect answer ever. So there you go. Thank you for that query to wrap us up. George, before we bring in our class to say thank you and farewell, is there any final message you want to share about wild and wacky weather before we leave them for the day?
I'm just going to answer one more question that I see in the chat.
Yes.
Somebody was asking about the most dangerous type of tornado that I wouldn't chase.
Go for it.
I don't like chasing tornadoes at night because it's very dangerous to see. And some tornadoes get wrapped up in rain in we call it the bear's cage. And if a tornado is wrapped in rain, they're practically invisible to see and super dangerous. So I try to avoid those.
The bear's cave is the best possible name for that phenomena of all time. So,
and you don't want to be in there with the bear.
No, absolutely not. George, this has been so much fun as always. The class has been over the moon. I'm going to bring in everyone to say thank you and farewell. So Miss Group, Miss Coburn, Mr. Bedard, Janet Metcalf, Mr. John Dowling School, thank you so much. Have
Awesome.
Bye for now, everyone.